Hello. I'm going to show you guys how to use your calculators for the one sample t-interval stuff that we did in this lesson. So firstly, if I have a list of data that I want to find the mean and standard deviation of that sample data for. So I'm going to go to Stat and then Enter for edit. And you're going to type that data into L1. So these are the Lay's potato chip bag weights that we had in that example. So I just typed those into L1. There can be things in other lists, it doesn't matter. We just want to make sure that those numbers are in L1. So then I would do stat and then calc and then 1-bar stats. It'll ask you what list. If you have an older calculator that doesn't bring up this menu, your calculator will automatically use L1 as default. There is a way to change that, but I just find it easier to put the data in L1 to begin with. Frequency list, we're gonna leave blank. Again, if you have an older one, it won't automatically ask you for that, so don't worry about it. And then we're gonna hit calculate. So it gives us a bunch of stuff. The two things that we are needing right now for this type of problem is we need the sample mean, so X bar, and then we need the standard deviation of the sample, which is the SX. So those are the two numbers that we would need for this problem. And then I would use those two numbers in the formula for a confidence interval to calculate that interval, like we talked about in the other video. But just to kind of go through, like 28.78, right? And then I would do the minus first, or you can do the plus first part. And then my critical value is 2.571. I like to do parentheses, standard deviation 0.402 over square root of n, which was 6. Right. And then I can do that same thing if I do second enter, and then I can go back and change that to a plus. And there's my interval, right? So I can do it old school with the formula, and that's fine. The other thing that I can do, as you probably imagined, there is a stat tests option here. So what we would do in this case, it's number 2, or I'm just kidding, it's number 8, which is just called t-interval. So you'll notice there are some that say like 2-samp. The one we use for a 1-sample t-interval is just called t-interval, and we do want to use t and not z. That is actually really important. That's kind of a big part of this whole lesson. Is we are using t because we only know the data for this sample. I don't know the population standard deviation. You will never use z-interval on your calculator or z-test. We'll always use t. So I'm using t-interval, and then you have the option of either using data or stat. So data would mean I put this information in L1 or in the list somewhere, which is what I did in this case. Stats would be, instead of giving you the data, if they just told you what the mean and standard deviation were, and I had that to type in right here, that's when I would use stats. In this problem, I know the data, so I'm going to use data. It wants to know what list you got it from, so L1. Frequency just means how many times do you want me to use each number? Just once, please. We're never going to change that. And then C level is your confidence level. We wanted a 95% for this problem, so I'm going to put 9.95, and that's all at once. If I put the data in the calculator, that's all I need to type here, and then I hit calculate, and then it's going to give me my interval. That interval might look slightly differently in those like later decimal places than the one I calculated with the formula, just because the calculator does not round. It uses all the decimal places of the mean and standard deviation, and it uses all the decimal places of the appropriate critical values. So this is actually a little bit more accurate than what we would have done by hand. Either would be acceptable on a test as long as I can see what your calculations were. As always, if you're not going to show the formula on your paper for this problem, you need to write 1 sample t-interval. So not just t-interval, 1 sample t-interval. Have that written somewhere on your paper, and that gets you out of having to write the formula. So that's always going to be true as long as you write the name of the test specifically. So 1 sample t-interval, you do not have to show the formula. Last thing I'm going to show you is how I could graph. So again, I have the data in L1. If I wanted to use my calculator to draw a quick graph of that data, I would do second y equals, and then I'm going to push enter on plot 1. I'm going to push enter on the word on to turn that graph on. For type, you can use either a histogram or a boxplot. Either would get the job done. A histogram if we're going to do it, but the calculator anyway, I find histogram easier. So I'm going to click enter on that one. And then L1 is where my data was. And that's really all I need to pick. And then once I've chosen those things, I'm going to do second quit to get out of there. If I go to graph right now, it may not show up just based on the window. So what you want to do is say zoom, and then number 9 is zoom stat. And then it'll zoom it to exactly what it needs to be to see all of the data. There's my histogram. Again, I'm looking for no major outliers. So yes, this is a little bit slightly skewed to the right, but because there are no kind of crazy major outliers in this data, it's enough to assume that the population is probably normal, because I don't see any kind of major deviation from kind of that typical area. So we're being very, 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 very lenient with this graphing. So this would be to check that third condition. Like I said, if you're going to just draw this on your paper, you need to label your x-axis like with numbers. So easy way to do that, if I hit trace, it'll kind of tell me what the x values are. So this box is going from 28.2 to 28.457 or 475. That one's going from 28.475 to 28.75, etc. So I could label my x-axis based on those numbers right there. But you do need to label it. Don't just draw this on your paper and expect me to know what that means. So make sure you're labeling graphs. But this is one way to get a histogram. Again, we could have chosen a box plot. That actually would have been a good way to see if there's actual outliers. So zoom 9, there's my box plot. And I can see from the box plot that it looks actually really symmetric based on the box plot. It's not a whole lot of skew at all, and there's definitely not any outliers. So that's another way that you can check that. But again, if you're going to draw this on your paper, you need to make sure that you label your numbers and don't just draw a random shape and expect that to cover you for conditions. So that is all for calculator. Good luck.